Hello, welcome to today's review session. This is the final part of the review. We've already done one and two, and so this is the final part. So we are trying to finish all the questions now. So to continue from this one, we are told that a golf ball is dropped from 15 different heights, and then the heights are in inches. And the height of the bounce as recorded is also in inches. And then we are given the regression model to be this. So we know that this is the model, which is bounce is equal to 0.3 plus 0.66 multiplied by drop. Now we are told that a golf ball dropped from 74 inches. And then we are told that it bounced 1 inch less than the expected. How high did it bounce? So first and foremost, let's try to find the expected bounds. So to find the expected bounds, we are going to have bounds equals 0.3 plus 0.66 multiplied by 74. So you can use your calculator to do this. So when you do this, we get 49.14. This is the expected bounds. And then we are told that, however, it is 1 inch less than the expected. So this is expected. So 1 inch less than this is going to give us 49.14 minus 1, which is 48.14. And so the answer is E. Okay, now let's proceed. In this problem, we are told that a consumer organization estimates that 33% of the household in a particular community have one television set. So have one television set. That is going to be, so let's try to put that information down. So have one. So if X is the number of television sets you have, we know that P of X equals 1 is what? 0.33. And then 37 have two sets. So P of X equals 2 equals 0.37. And then 24% have three or more sets. So probability that what X is greater than or equal to 3 is 0.24. Now the question is, what is the probability that a household chosen at random has no more than one television set? Has no more than one. So probability that what X is less than or equal to 1. Has no more than one means that the maximum they could have is 1. Or there could be some household that do not have television sets. So either you have one or you have none. That is what this one means. Have no more than one. So the maximum is 1. So this is how we write it. And we can solve this using the complement. So this is the same thing as what 1 minus probability that what X is greater than 1. We can use the complements to solve that. So this gives us 1 minus more than 1, we have people who have 2 and then 3. So that's going to be 0 0.33, no, not 33, 0 0.37 plus 0 0.24. So 0 0.37 plus 0 0.24, we add that, we subtract from 1, we get 0 0.39. And so that is the answer for that. Okay, the next one, let's do this one. We are told that which of the labeled points below will exert the largest leverage on a linear model of the data. So to be able to answer this, you have to refer to the previous notes. You have to understand what a leverage is. We talked about high leverage points. We also talked about influential points. So in preparing for this exam, it's good that you understand both of them. So for a high leverage points, we know that they are not far from the line, but it's far from the rest of the observations in terms of the x value. So we can see from here that if we draw this line like this point E here, it's closer to the line of best fits, but then again, in terms of the x values, it is far from the rest of them. But then when we draw the line, it's closer to the line. So it's not that influential. So we can see that point E is the answer. Now let's proceed to this one. Here we are told that a box contains 12 batteries, of which 7 are working, and start picking batteries one at a time from the box and testing them. Find the probability that at least one of the first 4 works. We have to find the probability of at least one of the first 4 works. This is the same thing as we can do the complementary. So P of what? At least one of the first 4 works. This is the same thing as 1 minus probability that what? None works. None of the first 4 works. So this is the same thing as what? 1 minus the probability that none of the first 4 works. So we know we have 12 batteries, 7 are still working. So how many are not working? 5 of them. Is that okay? So 5 are not working. I got that because I have 12 batteries, 7 are still working. So I know that 7 working, 5 not working. So to be able to find this probability, is the same as 1 minus. So the first 4. So probability that the first one I'm going to pick is not working. How many do we have not working? So that's going to be 5 divided by 12. That is the first one. Times the second one. Now, because we've picked the first one, the second one, it means that this 5 will reduce. So you're going to have 4. The total will also now be 11. And then the third one, 3 over 10. And then the last one, 2 over 9. So when you do this, you get 0.990. So then again, I used the complement rule to answer this. Find the probability that at least one of the first 4 working is the same as 1 minus none of the first 4 working. So this is how to go about that. Now let's solve this first one here. We are told that the probability that a college that a student at a certain college is a male is 0.45. So we could write the event. So we know P of M equals 0.45. The probability that a student at a college has a job off campus. So you have a job off campus is 0.25. So we know probability of what? Job off campus. So let's do J to represent job off campus. That is 0.25. The probability that a student at the college is a male and as a male is a male and has, so this is probability that you were a male and has a job off campus as 0.11. Now the question is, if a student is chosen at random from the college, what is the probability that a student is a male or has a job off campus? So we are just looking for probability of what? You being a male or is you has a job off campus. And this is what we are looking for. Remember, we know this formula already. This is the same thing as probability of what? Male plus probability of you having a job off campus minus the intersection of what? You being a male and having a job off campus. So this is, what is probability of a male? 0.45. Probability that you have a job off campus, 0.25. Minus probability that you're a male and have a job off campus, 0.11. So when we do this, and then we add, and then we subtract from 0.11, we get 0.59. So that is how to go about that problem. Let's get to this one here. We are told that a computer manager wants to test the reliability of some new and expensive fiber optic Ethernet cables that the computer department just received. The computer department received 5 boxes containing 50 cables each. So that means that we have 5 boxes. 1, 2, 3, 4, 5. And then each box here has what? 50 cables. Same thing for all of them. Then let's proceed. The manager does not have the time to test every cable in each box. The manager will choose one box at random and then test 10 cables from within that box. The question is, what is the population? What is the population? Population is the total. Is that okay? So the total population of the people living in your county or the people living in your city or something. So it's everybody. That is what population means. So population means that the total number of what cables. Remember, each box has 50 cables. How many boxes do we have? We have 5 boxes. So to get a total number of cables, we are going to have 5 times 50. That gives us 250 cables. So that is correct. Now let's proceed. Here we are told that a bag contains 12 red chips and 10 blue chips. So let's say this is the bag. So we have 12 red chips and then we have 10 blue chips. Then we are told that 2 chips are selected randomly without replacement. So without replacement means that you just pick a chip and you don't put it back. Is that okay? What is the probability that the 2 chips are both red? So let's try to do that. So the first chip, so it means that you pick red and red. So for you to pick a red chip, you are going to have 12 over, what is the total number of chips here? 22. Times, so now you have picked one red out. So if you have picked one red out, it means we are left with what? 11 red chips. and then 10 blue chips. So the total here will now be 21. Probability of you picking red again is going to give you 11 over 21. So all you have to do is to be able to just do this, and then they should give you 0.286. So you see, I put my box here, and then you have to understand whether replacement means that when you pick, you don't put it back. So it means that, for example, if I have 10 balls in this box and I pick one, I don't put it back. So it means the total number of balls in the boxes have reduced to 9. So that's what it means. So let's proceed. Good. So now we are here. A random sample of records of electricity gives. So you have to read this, and then when you read this, it gives us the model usage. Okay. So we are asked to explain what the slope line means. So what do we know about the slope line? So we can see from here that the slope, which we could call beta 1 or beta hat 1 as 0.3. What does that mean? So what it means is that, so when you look at this definition, it means that now what is the slope line here? The slope line here is what? Positive. Is that okay? So it means that on average, electricity usage increases by this, and then the size of the house is increased by 1 square foot. So that is what it means. So what it means in this problem is that you should be able to learn how to interpret the slope, and also not the slope alone, but also beta naught too. So you should be able to learn how to interpret those. You could also refer to your notes because we did a couple of examples in class. Okay, now let's do this. So here we are asked to fill in the missing information. So to fill in the missing information, what is missing here? Y bar is missing, we can see from here, and also R is missing, but we have this information here. How do we go about that? Now, what do we know? First and foremost, when we look at this thing here, we can see beta naught is negative 120, beta 1 equals 40. We can see from here. So we take note of that. And then we know you could look through your formula because I told you to write that formula down. We know that beta naught is equal to y bar minus beta 1 x bar. And then we also know beta 1 is equal to r multiplied by sy divided by sx. So we can manipulate these formulas and then compute for both r and then y bar. Let's try to do the r first. Let me use blue. So let's use this formula. What is beta 1? Beta 1 is 40. R, I don't know. What is SY? SY is 120. What is SX? XX is 1. So we can see from here that 40 equals 120 R. So R equals 40 divided by 120. And then you can use your calculator to do this. You're going to see you're going to get 0.333. So we can see that R is 0.333. That means that D and E are out. Okay, the next thing we want is Y bar. To use Y bar, to find Y bar, it means we are going to use this formula here. So what is beta naught? Our beta naught is negative 120. Because let's look at the formula. Beta naught equals Y bar minus beta 1 X bar. What is our beta naught? Our beta naught is negative 120. Y bar, I don't know. Minus beta 1 is 40. x bar. X bar is 2.3. So we have minus 120 y bar minus, what is 40 times 2.3? So we can use our calculator to do that. That is 92. So now we can see y bar equals negative 120 plus 92. So you can see from here, y bar equals, what is negative 120 plus 92? What did I do? I just added 92 to both sides of the equation. So what is negative 120 plus 92? That is negative 28. So that is how to do that. So we can see our y bar is negative 28, and then r is 0.3333. So to be able to save time, you can see that the y bars are different. So you can decide to do y bar first. If you're able to get y bar to be negative 28, straight is B, because the y bars here are very different. Let's go to the next one. So this question is just asking you to explain what r squared is. Remember, r squared is what, 90. So what is r squared? Is the variation in y that is explained by the explanatory variable, or x. And so we can see from here, all we have to find is what is our response variable and what is our explanatory variable. So when you read the problem, it says that using advertised prices for used for escorts, a linear model for the relationship between the car's age and the price it's found. So we can see that the response variable is the price, and then the x, or the explanatory variable, is the car's age. So we are told that the coefficient of determination is 90%. So it means that the changes in the car, in the age of the car, explain 90% of the variation. So all you have to do is go through a note and extend what r squared means. And then when you look at the explanation we did in class, you can relate that to this and then find the explanation. Now let's get to the next one. Okay, so we are here. So we are asked to determine whether the events are disjoint, independent, neither or both. Disjoint means they have their intersection is 0, or both of them cannot occur at the same time. Independent means that one event occurring does not impact the other. So we are told that in filling out a ballot for a president, the event of voting for the Democratic candidate and voting for the Republican candidate. So when you look at this, it's disjoint because you cannot vote for both. So they cannot occur at the same time. So then that is disjoint. Now let's get to this one here. We are asked to find the expected value of a random variable. So here we just want the expected value of the random variable. You could use Excel to do that. I have taught you that already, but for me, since this is the expected value, I find that it's very easy to do by hand. So we know for the expected value, which is E of x, is equal to summation of x times P of x. So all we need to do.
Okay, I found this on the web for go to.
So all that we need to do is multiply the x by their corresponding probabilities. So let's try to do that. So this is 3 times 0.14 plus 6 times 0.32 plus 9 times 0.36 plus 12 times 0.08 plus 15 times 0.10. That is all. So I think that you'd save time when you do it by hand if you just want the expected value. So If you want the standard deviation, that is when I recommend you to use the Excel. I've taught you that already. So the expected value E of X, you just do this and add all of them. So you can use your calculator to do that. And so when you do that, it should give you, so for example, let me continue here. So E of X equals, when you do 3 times 0.14, you get 0.42. 6 times 0.32, you get 1.92. If you do 9 times 0.36, you get 3.24 plus 0.96 plus 1.5. And then when you add all of them, you get 8.04. So that is going to be C. Okay. And then let's get to this problem. We are told that a magazine publisher mails a survey to every subscriber asking about the quality of its magazine. The publisher wants 100%, so all of its subscribers to respond. This 100% rate will correspond to what? The census. Census means everybody. So that is all about the one. That is all for the review. I recommend you spend some time, go through them, go through the various topics and all the sections that it's going to be covered in the test too. And I wish you good luck. Have a good one.